Hi Taylor. All right, so I've got your charts here, and I'm going to start with number one. And so the first thing that you have to realize is that, sorry, slope of a velocity time graph equals acceleration. Okay, so whatever we find when we find slope, we're always going to be finding acceleration. So if I start with your first chart, what I'm going to do is actually make a 3-column chart. And the first one is your time, 1, 2, 3, 4, 5, and it's nice that you've done it in ones because it's going to make the calculations really easy. The second, we'll have that be the velocity, and so that's 18, 21, 30, 36, and 43, I think. If I'm looking at that correctly, or is that 13 at the beginning? Sorry, I think it's 13. Hang on a minute here. 13, 21, 30, 36, 43. Okay. So if we make a column over here for acceleration, and we call that slope as well, so we know what we're talking about, then every time we move up the chart, it's just like doing first differences like you did in math when you were finding regular slope. The trouble is that because it's a curve, you're going to get a different slope each time. Maybe, because I'm looking at this and it's looking a little linear to me actually, so I know you're trying to find a curve of best fit, but maybe not. 21 minus 13 over 1 is going to give us 8, and that's going to be, it looks like your velocity is centimeters per second, so it's going to be centimeters per second squared, or per second, okay, because that's the slope. It's how fast the velocity is changing over time. So the next one's going to go from 21 to 30, so it's going to be 30 minus 21 over 1, and that's going to be 7 centimeters per second, And then we've got 36 minus 30. I'm just squeezing this in because I'm running out of space here. That's 6 centimeters per second squared. And then the last guy here, it looks like 7 because it's going to be 43 minus 36 over 1 is going to be 4 plus 3, 7 over 1 centimeters per second squared. So what I'm thinking is that 7 is a lucky number here, and that the slope of the graph actually looks constant to me, or pretty close. So I'm thinking that a line of best fit rather than a curve of best fit is where you want to go with this data, especially for the first chart. I'm going to try the other ones for you in a sec as well. So if you look at your numbers, if this was supposed to be a curve of best fit, then what we would be finding is that the slope should be increasing as we go up the chart. And we're not seeing that. We're in 8, 7, 6, 7, and it looks to me like almost like it should be a constant slope of 7, only maybe it's just, like there's all sorts of errors in this experiment, like friction and wind resistance and, just even measuring to a full second and all that kind of stuff. So I think that's what you're going for, is that the acceleration here is on average 7 centimeters per second squared, and that's actually your slope. And so if you're doing your slope per inclination, then the slope for an inclination of, oh, I see, wait a minute, all right. So your inclination, is that your IL? I wish you could answer me. Maybe that's what that is. Are you changing it? I don't know what that is. I might have to call you and ask you what that is. Because I thought that what we were doing was all 6 of these charts, each one was representing a different sort of angle of inclination of your track, and that you were measuring 1, 2, 3, 4, 5 centimeters or seconds and calculating the velocity by using the distance traveled. So I'm not sure what these numbers are. What's IL interval? Are you dividing these numbers by the time? Oh, and these are point ones. Sorry, Taylor, my eyes are not what they used to be. If those are points, I can see decimals now that I couldn't see before. God, I'm an idiot. Okay, so there's points in front of all of these. It's actually going to make your answers turn out the same anyway, but put points in there for me, okay? And so it'll still give you 8 centimeters per second squared, I think, or point, no, it'll give you 8. So you want 2 decimal, decimal, decimal everywhere, okay? Change that for me. So I might have to call you and check on that because I'm thinking that now that it's, we're done number 1 and we worked out the acceleration, then you could say like the acceleration for whatever angle you were using for angle 1, say it was 30 degrees or something, that the acceleration is 7 centimeters per second squared. And then I'm thinking that maybe for the second one you moved it up to 40 or whatever you did. I'm going to call you and find out if that's right or not. And I'm going to calculate these other slopes for you, and I'm just going to send you a slide with all of that in a separate video in a minute. Okay? So first have a look at this, and then I might talk to you on the phone, and then we'll see if we need to make changes.